Okay, so some papers are making their way around the classroom. If anybody ends up with a bunch of extras, if I could have you just bring them forward, put them at the table, and if you're getting here late and you haven't, and the stack of papers has missed you, you can come to the front. There's a paper that you'll need to pick up. It's a formula sheet, okay? And we are continuing on our discussion of statistical inference topics, and we've so far covered confidence intervals, and we're in the middle of hypothesis tests. So we will continue on with hypothesis tests. Okay, I guess I should just check in with you guys, see how everybody is doing. So how are you guys doing? It's 8th week Friday. We only have 2 weeks left in the quarter and plus finals week. So things are really wrapping up. How are you guys doing? Good? Okay? Surviving? Barely? Or thriving? Well, okay. I hope none of you guys are struggling too bad, but I know that can be a reality for some. So again, my encouragement is, you don't have to face your struggles alone, and if you need help, either in this class or any of the other classes, for this class, I'm happy to offer help, at least with our material, and then as far as your other classes go, I'm sure the other instructors and TAs are willing to help, and there are also resources available on campus for you guys. Okay, so we're going to continue on our talk on hypothesis tests, and we left off on Wednesday. We said, when you do a hypothesis test, you established your hypotheses. Okay, and on Wednesday, the type of hypothesis test was a hypothesis test for a population proportion P. Okay, and so in part one, where you establish your hypotheses, the null hypothesis, when we're doing a hypothesis test for a population proportion P, was that P is equal to some value P0, and then the alternative is that P is either greater than or less than or not equal to P0, okay? Greater than or less than, okay? And then the second step was to check your conditions. We called this our preparation step. And this was checking conditions and selecting a significance level alpha. Okay. And then the third step is to do all of your calculations. And the goal of the calculations is to get the p-value. Okay, so the goal is to find a p-value. So for a hypothesis test for population proportion P, okay, so we can also say this is one that deals with one sample. We can break down our calculation step into just kind of a few sub-steps. One is that we have to find p hat, which is going to be x divided by n. Okay, and once you find your p hat, you're going to get the standard error. The standard error is given by the formula P0 times 1 minus P0 divided by n. Okay, and then you get your z-score, which is going to be p hat minus P0 divided by the standard error. Okay, if you have your formula sheet that I've just passed out, you will see all of this is written for you in that kind of on the left-hand column, the second box down, it will say hypothesis, tests, proportions, one sample, and it says, you know, your hypotheses is that your null is p is equal to P0, or this is your alternative, and it also tells you you're going to get p hat is x over n, standard error is P0 times 1 minus P0 divided by n inside the square root, and z is p hat minus P0 divided by the standard error. Okay, so this formula sheet will be given to you for the final exam. Okay, and then on next week's quiz, the kind of the relevant parts, basically the top half of the formula sheet, will also be printed on the quiz as well. So you know, as far as memorizing all of this stuff, you don't have to do it. The important part is, and that we'll see, you know, in the coming days, is that you will have to recognize, for this type of problem, I need to use this set of formulas, or for this type of problem, I need to use a different set of formulas. Okay, and that's going to be the important part. Okay, but as far as, you know, your calculations go and the formulas, I'm not expecting you guys to memorize all of this. So this formula sheet will be provided as part of the final exam and on next week's quiz as well. Okay. And so anyway, we get to this point, we get a z-score, okay? And it's not listed here on the formula sheet, but the next part, once you get your z-score, or we might call this our test statistic, is to look this up in our table to get the relevant p-value, okay? So again, our goal of our calculations is to find a p-value. We kind of plug our values into the formulas to get a z-score. Now that we have a z-score, you look up the z-score, to get your p-value. Okay, and I will detail this part on the next page. Okay, so details on the next page. Okay, and so once you've completed that step, so you now have your p-value, now you use your p-value to make a conclusion. Okay, the p-value is the probability of observing our data, or something more extreme, if the null hypothesis were true. Okay, and so in our example in our last class, we said, you know, what's the probability that, you know, after flipping the coin a bunch of times, we end up getting 700 heads. Okay, so if the resulting p-value ends up really small, what does that mean? That means we reject our initial belief. We reject our null hypothesis. Okay, so we use the p-value to make a conclusion, and kind of the rules go like this. If the p-value is smaller than some level, okay, so if the p-value is less, and we use the significance level to make our decision, okay, if the p-value is less than alpha, this means our p-value is small, and we will reject the null hypothesis. If the p-value is less than alpha, this means our p-value is small, and we reject the null hypothesis. Okay, and on the other hand, if the p-value is greater than alpha, okay, we do not reject the null hypothesis. So these are the steps for carrying out a hypothesis test. Let me give you kind of these details on looking up the z-score to get our p-value. Okay, so far so good? Yes, question?
What if it's equal to?
If it's equal, then that rarely happens. It's technically possible, but well, I guess the probability of it is 0, but because your table is finite, generally we will say greater than or equal to right here, if you want to throw in the equal somewhere, but usually it's a less than or a greater than. Okay. All right, let's cover details on looking up the z to get the p-value. Okay, so it really all depends on the alternative hypothesis, okay? So look at the sign in the alternative hypothesis. Okay, if there is a greater than, less than sign, okay, the p-value is equal to the area to the left of z. Okay, which basically means look up z in the table and use the area that the table gives you, right? If the alternative has a greater than sign, the p-value is the area to the right of z. Okay, which means look up z and then subtract that area from 1. And if the alternative has a not equal sign, then the p-value is 2 times the tail area. Okay? The tail area is always the area away from 0. Area going away from 0. Meaning it's the area to the left if z is negative, it's the area to the right if z is positive, okay? Okay, kind of a shortcut is just a practical tip is whatever your z is, okay, look up kind of the negative of that value. Look up kind of the negative version. Take that area and multiply it by 2. And that's for if the alternative has a not equal sign. You're going to p-values 2 times the tail area. All right, is this okay? All right, so let's just do a practice problem here to just make sure that we got this right. Okay. All right, so let's say you set up your hypothesis. So here's just a practice problem. Okay, we'll say your null hypothesis is that P is equal to 0.3. The alternative is that P does not equal 0.3. Alpha, we're going to say alpha is 0.05. Okay? And then you go through and we'll just pretend like we've done all the calculations for the calculation step. Okay, so we'll pretend we've done our calculations. Okay, and let's say we get z equal to, let me pull out a reference table here. Okay, so let's say we get z equal to 2.13. Okay, and so the question is, what is the corresponding p-value? Okay, and then we'll say we've got some answer choices. Let me see. Fire up our clicker box. Okay, is this working here? Okay, so go ahead and work through this, and then we'll take a look. Okay, I'm going to go ahead and click stop here, and let's take a look. Okay, and yes, the answer here is D, but let's just kind of address how we went about doing this. Okay. All right, so the key here is that we have a not equal sign in the alternative hypothesis, right? So the alternative has a not equal sign, so the p-value is equal to 2 times our tail area. So we look up 2.13, okay? All right, and then if we, if I draw a little picture here, okay, when I look up 2.13, this will tell me that my area is 0.9834, okay? And that's going to be this area over here. Now, our tail area is always the area to the right, okay? So I believe on the previous page I said, you know, whatever z is, look up the negative version, okay? So if z was negative 2.13, we'd look up negative 2.13. But because it's positive 2.13, we still look up negative 2.13. So whatever it is, we're going to look up the thing, the negative version. So we look up negative 2.13. Okay, and when I look up negative 2.13, I have 0.0166. Okay. That tells me that this chunk over here is 0.0166, okay? And I'm going to multiply that by 2. So my p-value will be 2 times 0.0166, which is 0.0332. It's going to be my answer there. Okay. Yes, question?
Does the tail area correspond to the significance level or no?
The tail area is not our significance level. Okay, we will. So this is the end of step 3. Okay, if we look at the kind of the hypothesis test, you know, we set up our hypotheses, we check our conditions, we do our calculations, and what I had you guys do was go from the z-score to get your p-value. Once you have your p-value, now we do our conclusion, and that involves comparing our p-value to alpha, and in this case, if alpha is 5%, how does our p-value compare to alpha? Our p-value is smaller than alpha, right? So, you know, if we were to do our conclusion, here our p-value is equal to 0.0332. This is smaller than alpha, and if it's smaller than alpha, then that means we reject the null hypothesis. Okay. That's how we go. Yes, question?
On the previous slide, did you say that if it's equal to or greater than alpha, we reject the alternative, or did you just say we cannot reject the null?
All right, what did I say? It says we do not reject the null. Okay? Yeah, we never actually say we reject the alternative, and we never say we accept the null. Okay? I'll spend time on Monday discussing kind of the nuances and intricacies of these conclusions that we can make here. All right, this is okay. This the process that we did to get from our z-score to a p-value. Okay. All right. So that's hypothesis testing for a population proportion P, and we can do the exact same thing. Oops. And we'll do hypothesis testing for comparing two proportions. Okay. Okay, so this will be proportions with 2 samples. Okay. So yes, next week on Tuesday you'll have a quiz, and I have, under week 9, I've posted a practice quiz. Okay, so after today's lecture you should be able to do most of the practice quiz, although there's going to be some conceptual questions talking about type 1 and type 2 error. I'll talk about type 1 and type 2 error in Monday's lecture, okay? But as far as kind of the steps in the calculations for going about, I'm hoping at least you can start to practice a little bit this weekend. Okay, so we'll have the same 4 steps, right? We set up our hypotheses. Okay, and this time the null hypothesis will always be that P1 is equal to P2. Okay, this can also be written, and they are exactly the same, to write it either way. It can also be written as P1 minus P2 is equal to 0. Okay. The alternative is going to be that P1 does not equal P2, or that P1 is greater than P2, or that P1 is less than P2. Okay? And likewise, they are equivalent to writing P1 minus P2 is not equal to 0, or is greater than 0, or is less than 0. Okay? And the idea here is that we are looking at two samples. Okay, so here's kind of our big idea. Is, we look at two samples. We look at two samples taken from two populations, right? And our two samples have different proportions of whatever it is that we're looking at. Okay? And so the question is, well, if our two samples are different, does that mean the respective populations are different as well? Okay. So during election season, they always have they always do different demographic groups, and they'll say candidate A among this demographic group has this much support. But if you go to a different demographic group, the candidate has a different level of support, right? And so whatever candidate among white males has this much support, but if you go to minorities and females or something, the amount of support is drastically different, and they say all sorts of stuff, right? Basically, that's what we're doing here, except we're looking at just a sample, and based on what we see in a sample, we're asking, well, does this mean that the entire population is different? Okay, so if we say, here I took a random sample of, I don't know, UCLA students, and we surveyed them a question, okay? And then we go to USC and we ask the same question, okay? We take a random sample of SC students, we ask them the same question. Maybe maybe the two populations, or your two samples, have slightly different proportions, okay? Whatever, okay? And does that mean the respective populations are the respective populations different? That's what we're asking, okay? So when we set up our hypotheses, we set them up so that the two populations have the same proportion. That's our null hypothesis. And then the alternative is that the two populations are different, or that one is higher or lower than the other, okay? So after we've set up our hypotheses, we go about, we check conditions, and we select alpha. Check conditions, we choose alpha, our significance level. Again, checking conditions is the same as before. Random and independent, large sample, big population condition, all of those things. Choosing alpha. If alpha is not specified, you're going to assume alpha is 5%. Okay, part 3, this is the calculations. Calculate your p-value. And the steps for calculating p-value, they are different, but these will all be labeled out for you. Okay, so the first part will be find the overall p hat. Okay, the overall p hat is going to be the total number of successes x1 plus x2 divided by n1 plus n2. Okay, so you can kind of take a look on your note sheet, your formula sheet. Okay, you've got your overall p hat. This is this. You're also going to need p hat 1, which is the proportion for sample 1, x1 over n1, and p hat 2, which is going to be x2 over n2. Okay, so you find this, you find your proportions, and then you find your standard error. You get your standard error. The standard error here is using the p hat from this step. We do p hat times 1 minus p hat divided by 1 over n1 plus 1 over n2. And then we're going to get our z-score, which is going to be p hat 1 minus p hat 2 divided by the standard error. Okay? So all of this, again, we do all of this work to kind of get a z-score. And once you have your z-score, the next step is to look up the z-score to get your p-value. Okay, and the same rules apply here. Okay, look up the z-score to get a p-value. Okay, same rules. If the alternative has a greater than, you're going to the right. Alternative has a less than, you're going to the left. Alternative has a not equal, 2 times the tail area. Okay, I don't have to rewrite all that down, right? So look up the z-score to get a p-value. Use the same rules as last time. Okay, and then now that you have your p-value, use the p-value to make a conclusion. And this is the same as before. If the p-value is less than alpha, reject the null hypothesis. If the p-value is greater than alpha, do not reject the null hypothesis. Okay. All right, is this okay? Okay, so I'm going to write out a problem, okay? And again, the key part in all of these problems is to recognize, oh, this is a problem where I've got 1 sample, or this is a problem where I have 2 samples. Now that I've established that I have 2 samples, this is the way I'm going to do my calculations, or this is the way I'm going to set up my hypotheses. Okay, so over here I will say in 2015 a survey was conducted. Okay. The survey asked, we'll say 1,040 random people the survey asked 1,040 random people about their opinion on whatever, Uber. Okay, I'm just completely making this up, so I don't know what people's opinions on Uber were in 2015. Okay, and we'll say 100, I don't know. All right, we'll say 210 people had we'll say a positive impression of Uber. Or we'll say positive, have used it, I don't know, okay, whatever. All right, 2015, that was, okay, and then we'll say in 2017, another survey was done. And this time we'll say 620 people were asked. And we'll say 230 people whatever responded affirmatively. Okay. Okay. Again, we'll say 620 random people. Okay. And so we'll say has the proportion of people, we'll just say who like Uber increased. Okay. Okay, so we'll do that. Okay, in this setup, do we have one or two samples? We have two samples, right? Okay, so we've got two samples. And so therefore, we're dealing with proportions, right? Later on, we'll, as you can see on your formula sheet, we're going to have to deal with means. But right now, we're only dealing with proportions. So two samples, we've got proportions, we're doing a hypothesis test. Our null hypothesis is going to be what? The null hypothesis is that P1 is equal to P2. Okay, so we can say that P1 will be the kind of proportion in 2015, and P2 will be the proportion in 2017. Okay, what is the alternative? Okay, has the proportion of people who like Uber increased? Okay, what does that mean? That means we're expecting P2 to be larger than P1, so we would write P1 is less than P2. Okay, is that all right? Setting up our hypotheses, this means the proportion in P1 in 2015 is less than P2 in 2017. Okay, and that implies that the proportion has since increased here. Okay, now I guess we will go about and do our calculations. And I guess for the interest of time, I'll just do these calculations. I'll walk us through them. Okay, so well, we should check our conditions, but we'll just say conditions are met. We'll use alpha equal to 0.05. Okay. All right, so we'll get p hat. Our overall p hat is going to be the total number of positives. So we're going to say 210 plus 230. So this is x1 plus x2 divided by n1, 1040 plus 620. So in the numerator, I have 440, 210 plus 230. I have 440, and in the denominator, 1040 plus 620, I have 1660. So I have about 0.265. Okay, this is p hat overall. My p hat 1 is going to be 210 divided by 1040. And I get 0.2019. And my p hat 2 is going to be 230 divided by 620. 0.371. Alright, is this okay with everybody? Alright, and then so this is my overall p hat. I'm going to run out of space here. I'm going to just do my standard error calculations, which is going to be p hat times 1 minus p hat over 1 over n1 plus 1 over n2. So I have 0.265 times 1 minus 0.265 times 1 over 1040 plus 1 over 620. To make my life easier, I'm going to just do 440 divided by 1660. This gives me kind of a decimal value, 0.26506, whatever. And I'm going to do that. I'm going to do answer times, parentheses, 1 minus the answer, times, parentheses, I'll do 1 divided by 1040, plus 1 divided by 620. And then I'll take the square root of that value. I get a standard error of 0.02239. 0.0224. This is my standard error. Okay. And then now incorporating this into my z-score, I'm going to have z being p hat 1 minus p hat 2 divided by standard error. So I will have 0.2019 minus 0.371 divided by 0.0224. It's going to get a little bit hairy here. So p hat 1 will be 210 divided by 1040 minus p hat 2, which was 230, divided by 620. Okay, I get a z-score of negative 7.55. Oh, this is extreme. Okay. So my z is negative 7.55. So if I were to try to look up negative 0.755, z is equal to negative 7.55. So this is not on the table, right? Okay. But we can say that the area, right, so my p-value, because the alternative has a less than sign in it, my p-value is going to be the area to the left. So if I'm out at negative 7.55, I can tell you that whatever this area is, this is going to be very, very small. Okay, so my p-value is very small. If I go to my z table, I just know that it's going to be less than, 0.002 or less than whatever. Z is negative 5. The area to the left is, a bunch of zeros and a 2. So my p-value is, whatever it is less than that. Yes?
Okay, so and then you said for two proportions, do we always set them equal to, for the equal, do we always set them equal to each other, equal to the average of them?
And the null hypothesis is always that they are equal to each other, but we don't actually specify what that value is in the null hypothesis. The null hypothesis is always just p1 is equal to p2, but we don't say that p1 and p2 are equal to some number. Okay, so here my p-value is very small. Therefore, if I compare my p-value versus alpha, the p-value is less than 0.05, and therefore I will reject my null hypothesis. And that is that's the conclusion that we make. We say we have evidence that the proportion who like Uber has increased. Okay, we'll end here.